Okay, what do you have for ionic bond definition? That's the definition, a bond between a cation and an anion. That can happen because the metal transfers electrons to the nonmetal, or I've got a cation and an anion, and they want to come together to form a compound. What's a good way to know that you're looking at something that's an ionic bond? So if there's you know for a fact that this is an ionic bond that you're looking at if there's a polyatomic ion, or if there's a metal there. I mean, yeah, metal, non-metal, but if there's a metal, then there has to be a non-metal because you can't have metal. So if you look at if you're looking at a compound and trying to decide how you want to name it or determine if it's ionic or covalent, then if there's a polyatomic ion there, it's ionic. If there's a metal there, it's ionic. If you don't have either of those options, it can't be ionic. Okay, cation. First compound. Who's the positive ion? How do you know the potassium's the positive ion? What? Yeah, it's a metal. Metals lose electrons. Metals don't gain electrons. So the metal is going to be the positive ion. And what's its charge? How do you know it's +1? Column 1. Okay. So because I know for a fact that the potassium has no exceptions to the fact that it's a +1, so then the fluorine has to be the negative, and what's its charge have to be? Has to be -1. It also has a rule that says its charge is -1, but it's double verification. And the name of this? Okay. Next one. Cation. Calcium. Charge. Why? Column number 2, there aren't any exceptions to that rule, so it's a +2. That automatically forces my oxygen to be a -2 charge. And the name of this substance? Calcium oxide. Okay, next one. Cation. The cadmium is the cation. Let's look at the anion's charge. The anion has got to be my bromine. And do you guys know what the bromine's charge is going to be? I heard two things. I heard +1 and -1. It's -1. It's second to last column. It's a halogen, so its charge is -1. So if this bromine's charge is -1 and all bromines in the compound, its charge is -1. So I've got a total of -1 and -1. So the cadmium's charge has to be what? +2. This is cadmium. Sorry. Cadmium bromide. Cadmium is one of the elements that's in the transition metal area. And with those, we typically have to give an oxidation state. Why didn't I not write calcium 2? What was the reason that I had to give an oxidation state for substances? Like, why do I need to say iron 3 oxide? Because it's flexible. I could have more. There's a 2 and there's a 3, so it could be either one. I do not say cadmium 2 here, even though it's a transition metal, because it's one of the transition metals that doesn't have a variable oxidation state. How do you know that? Because it says, look on the periodic table, it says +2. There isn't anything else there. When I go to the iron one, it says 2 and 3. When I go to the cadmium one, just the +2. Also, the cadmium and the zinc and the silver, they're all touching each other. And those are the ones that are transition metals whose oxidation states don't change. So you just say silver 1 or cadmium 1 or cadmium 2 or zinc 2. You don't need to say that. You could just say silver cadmium, and zinc, and not give an oxidation state because this oxidation state is not variable. All right, how about the next one? Cation. The sodium, and it has to have a +1 charge because it's column number 1, but it says oxidation numbers. So there's actually a phosphorus in here that's positively charged. There's an oxygen in here. What's the oxidation state on the oxygen? -2. So what's my phosphorus got to be here? +5. So this phosphorus is a +5 because what I have is one too many oxygens. So I have all of this negativeness, which is a -8. And over here I have 3 sodiums. So this here is a +3. So I still need to cancel all of this out. So the phosphorus needs to be a +5 to make that happen. Name? Sodium phosphate. So remember, if you're required to go the other direction, you get the name sodium phosphate, and you need to come up with Na3PO4. The way you do that is knowing that the phosphate's charge is a -3 and the sodium's can only be a +1, so you need 3 of those. Okay, next one. Who's the cation? Who's the anion? So if the oxygen is a -2, then the bromine's charge in this case needs to be what? +3. The oxygen, there are 2 of them. That's -2, -2, so that's -4. I need to have a leftover -1 charge because this is a polyatomic ion with a -1 charge, so my bromine needs to cancel only 3 of those 4 negatives out. And the name of this thing? Bromide. This is one of the polyatomic ions, bromide. Okay, next one. Cation. Copper. Anion. Chlorine. Charge on the copper? I don't know. Charge on the chlorine? -1. It's the same thing as the bromine is because they're both halogens. So it's -1, -1. So now what's the charge on the copper? +2. So since I didn't know because the charge is variable, what do I need to call this? Copper 2 chloride. Okay. Number 7. What do we got? Sodium, hydrogen, and carbon. Those are all cations. And the oxygen is the anion. The oxygen's charge is -2. That gives us -6, and I have to cancel all that out. The sodium is a +1 because it's in column 1. The hydrogen is a +1 because it's with nonmetals, the carbon and the oxygen. And then the leftover charge is +4 for my carbon. And what's the name of this? Sodium hydrogen carbonate. Okay. Next. The nitrogen is the cation. The oxygen is the anion. The oxygen's charge is -2. The nitrogen's charge is +3. It looks really similar to this bromate here, right? This bromate. The formulas look the same, so they're going to kind of work out with the same charges. The name of this thing? Nitrite. Okay. How about the next one? Cobalt is my cation. My anion is chlorine. My chlorine's charge is a -1. So this time my cobalt's charge is a +2. So it's cobalt 2 chloride. Next one. What? Skipping one. sodium, and no, it's not a carbon, it's a chlorine. And then oxygen. The oxygens are a -2, the sodium is a +1. So in this case, the carbon or the chlorine is going to be a +5. And the name of this? Sodium what? No. Chlorate. Okay, next one. Nope. Nickel and hydrogen. The hydrogen rule, when hydrogen is with a metal, is the hydrogen is a -1 charge. So it's -1, -1, so the nickel's going to have to be +2. So this is nickel 2, and then what's the last part of this? What have we been doing with the suffix on all of these anions?
Dihydrogen.
Nope. Say again? No. That's OH. It's "ide." Every single one of these things ends in "ide." So I have to do the same thing with the hydrogen because the hydrogen is now a negatively charged thing. So the word is hydride. You might have heard that word used in this substance here is used in a battery, a fairly common rechargeable battery. They call it nickel metal hydride, but it's Ni2 or nickel 2 hydride is the actual formula. So the last one here, this one's tricky. There's a magnesium. So the magnesium's charge is what? The magnesium's charge is +2 because it's in column number 2 and there aren't any exceptions to that rule. Magnesium's charge has to be a +2. So now the oxygen, there are 2 of them, and the 2 of them need to distribute one single -2 charge. So what's the charge on the oxygen? -1. Each oxygen has a -1 charge. So this is magnesium peroxide. So initially you would have thought that the oxygen's charge was a -2, but if in this case the oxygen was a -2, then that gives you a -4, and then you'd have to say the magnesium's charge is a +4, and it can't be. It's in column 2. It can only be +2. So this is the only time you're going to see this, where the oxygen gets superseded by some other substance whose rule can't be varied. The oxygen rule is almost always -2 for the oxygen, but it's only almost always. And in this case, we were forced to make it a -1 because the magnesium's rule is set in stone. It is +2.
Why is it called peroxide?
I don't know. Why is your name Seth? That's literally the answer to that question. Like, why is it called that? Because somebody, I don't know how many, probably 100+ years ago called it that, and we've been stuck with it. Because it doesn't make any sense, because per usually means more. And so the only thing I can think of is they're saying it's more oxygen, but that's not how that usually is worded, or that's not how that is usually used, but that's what we got. Okay, so we're going backwards now. We have sodium and we have sulfide. So who's the cation? So my sodium is my cation, so I'll put that here. And I know its charge is +1 because it's a sodium and it's in group 1. Sulfide means a sulfur by itself. And what column is the sulfur in? It's in the -2 column. It's in the oxygen column. So the sulfur's charge is a -2. So then my formula needs to be Na2S. All right, so we have copper 2 oxide. We're coming up with a formula for this. What's really nice about going backwards with these transition metals? I was told flat out that this is a copper with a +2 charge on it because I have to be told. And so then the oxygen's charge is -2. So then this formula is just CuO. You guys are going to make some of that in a few weeks. Aluminum and phosphate. So, all right, I have an aluminum here. I have an aluminium here. We are the only country in the world that says aluminum. Everybody else says what?
Aluminium.
Aluminium is actually, if you look at it, you're like, oh yeah, that is actually how I should be pronouncing that.
Do they have an extra I? Like in the way they spell it?
Yeah, it's spelled differently everywhere else. It's just us.
Oh, okay.
It's like, right. That is a way you can find out where the person's from. Like asking them what the temperature is, and if they respond in Fahrenheit, you know where they're from. All right, so I have an aluminum. This one's a little tricky, and I would do this one piecemeal. What I mean by that is I would put down a phosphate here, and I'd know the phosphate's charge is a -3. And do we know the aluminum's charge? Or how are you supposed to know the aluminum's charge? It's 3. On the table it says +3. So the formula here is AlPO4. That's it. But I asked for all the anions and cations, so now I'm going to have to disassemble this phosphate group here. So I'll put a phosphorus over here and an oxygen here. And the oxygen's charge is -2. So what's the phosphates group's charge got to be? +5 again. Okay. All right, so lead 4 sulfate. Great. So I was told the lead has a +4 charge on it. And we can do this one the same way we did the last one. The sulfate is an SO4 -2. So the formula here is going to be 1 lead and 2 sulfates to get the charge to cancel out. Then I'll say that the oxygens are a -2, and in this case the sulfurs need to be a +6.
When you have the sulfate ion in the parentheses and the 2 below, that's just saying there's 2 sulfate ions.
2 of everything that's in the parentheses.
Okay,
so 2
there's
sulfates.
2 sulfurs and then there's 8 oxygens. Oh no. So
There's 2 SO4s.
okay.
So that's a good question, common question. So what we need to be thinking about with this would be, this is a lead, and this lead has an SO4 and an SO4, 2 separate SO4s. We treat this as a particle. Instead of saying that there are 2 S's and 8 oxygens, I mean, yes, that's how many atoms we have, but they're not grouped together.
Talking about just 2 particles.
I'm talking about 2 particles of sulfate. All right, silver chloride. So I have a silver and I got a chloride. The silvers are +1, the chlorides are -1, so this is just AgCl. I have a potassium with a plus charge. I have an oxygen with a -2 charge. So then my potassium needs 2 of those to go along with my 1 oxygen. I've got a manganese 5, so Mn +5, and nitride, which is an N. So what's the charge on nitride? What does this word mean, nitride? What does chloride mean? What does fluoride mean? That's by itself. It's not in a combination. It's not a polyatomic ion. It's a negatively charged nitrogen. So I have a nitrogen that's got a negative charge on it. And where is it on the table? It's in the -3 column. How do I know it's in the -3 column? The fluorine's the -1 column. The oxygen column is the -2 column. The nitrogen column is the -3 column. So how do I get these guys to come together? It's a little kind of big. There's 3 manganese and 5 nitrogens. Why so many?
is
The least common multiple between 3 and 5 is 15. So I need 3 of these guys to get me up to plus 15, and I need 5 of those guys to get me up to minus 15. Your question?
Oh, so the reason that it has to, how do you know that the nitrogen in the function on the table says it can be plus or minus 3, 5? So how do you know it's just not nitrogen negative 5?
In ionic compounds, just use the -1, -2, -3. The only time that the nitrogen is going to have an odd charge, like a -5, is if it's in a covalent compound
So it's
with probably an oxygen or a fluorine.
only when it's more like forced.
When it's forced to. Because what it wants to do is it's trying to look like the closest knowable gas, and it can do that if it grabs 3 electrons to look like neon. That's what it wants to do. But if it gets forced into doing other things, then it got forced into doing other things. But what it wants to do is to be -3. I'll show a chart here, but before I do, that's it for this homework.